Welcome back, ladies and gentlemen. Professor Connect here, bringing you guys a short video this time, going over function notation. Now, this guy's going to be a little bit shorter than normal simply because this guy actually has some, a lot of ease that goes into it, but this guy connects to a couple different ideas. Now, here's a weird part. Function notation is actually covered at different points depending on your mathematics curriculum. Some people actually learn function notation super early, like in geometry and algebra 1. Some people don't learn it till algebra 2, and some people don't even learn it till pre-calculus. So what exactly is it? Well, we're all probably familiar with the example of like y equals, let's say for example, mx plus b, right? This is not function notation. This is actually a normal notation for students. When I say function notation, it's actually a substitute for y. So instead of saying y, I might say f of x. And that's actually exactly how I say this. I pronounce this as f of x. Now, what the heck does that mean? The function in terms of x. So basically, if I say this, I'm saying the function in terms of x. Now, what does that mean? It means whatever this is, like if I say f of x equals mx plus b, if I say this, it means that the function, the only changing variable, if I were to plug in a number, will be the x. M will be constant and b will be constant. For example, let's say I say let's say I say f of x equals mx plus b. Now let's start with a super basic example. Let's say that you have a function, and normally you would say, well, y is equal to 4x plus 7. Okay, so in function notation, I will rewrite this as f of x is equal to 4x plus 7. Now, here's the fun part. If you learn function notation, your teacher might say, in Algebra 1, they might say something like this, solve when x is equal to 3. Okay, this would be inside of Algebra 1. They might say, solve this when x is equal to 3. And of course, that's pretty simple. If you have function notation, it's actually even faster because you can say this exact thing by just saying this. F of 3 is equal to 4x plus 7. And then they basically are asking you, what is f of 3? When they're saying this, they're just saying, what is the equation when x is equal to 3? So it's actually just that straightforward and simple. So f of 3 is equal to 4 times 3 plus 7. So if I do that, 4 times 3 will give me 12. 12 plus 7 is 19. So f of 3 is equal to 19. Or I could say y is equal to 19. And so this is function notation. Now, for those of you who are like, why the heck does this even exist? Function notation actually exists because it allows us to do a couple different things in higher level mathematics. For example, people use function notation to actually help them identify different parts of equations. Places where function notation gets used, when you start learning about something called inverses, oftentimes they will use function notation. When you start learning things like derivatives, oftentimes they will start using function notation. So these are just two really, I won't say basic, but they're somewhat complex, but they are sort of basic. They do use this in a much more basic way. They use this to just identify how to plug in variables into an equation and what those variables actually mean. So that's been the basics of function notation. Not super complex as an individualized concept, but still probably deserves its own little short video. One thing I do want to tell you though, is if you were in a physics class, or in calculus, you might actually see something like this, f of t. Or you might see f of x, or you might see f of any variable, like you might see f of y. Keep in mind, it doesn't matter if this is f of x, f of t, f of y. The thing that matters then is context. F of x means you're changing whatever the variable is for x, so you're changing x. Obviously, the rest of these are going to be changing y, changing t. Inside the physics world and inside the applied calculus world, like AP Calculus, this might be t might equate to something like time. So f of time, meaning f of a real scenario. Inside of physics, we might say f of y as in like the y position. Or it could literally just mean the y variable. So I'm giving you guys a heads up because you might see f of t, f of x, f of y. But what that's saying is this is the variable you are substituting for within f of that. Okay, so that gives you guys a really basic understanding, some places it's used, some other common notations using function notation, like some variations of it that you might see, especially in classes like physics, pre-calc, and calculus. because for those of you guys who don't know, physics is just made to apply calculus. So if you guys have any questions or comments, leave them in the comment section down below and I'll try to make sure to answer them. Thank you for your time. Share and like the video if you did. Enjoy it, and I hope to see you guys in the next video.